You are listening to JS Party, the award-winning weekly celebration of JavaScript and the web. Thanks to our friends at Fastly for shipping our shows super fast all around the world. Check them out at fastly.com. And to our partners at Fly. Deploy your app servers and database close to your users. No ops required. Check them out at fly.io. Okay, hey, it's party time, y'all.
Hoi hoi! Welcome to JS Party. I'm your host this week, Nick Nisi. Hello, and I am joined today by Amelia. Amelia, how's it going?
It's good. I'm very excited about today's episode.
Yeah, it's going to be a very colorful episode, I think. Speaking of which, we have a special guest, and that is Adam Argyle. Adam, how's it going?
What's up? Can I use colorful language? Y'all have a healthy beep button in there, right?
Sure. Yeah, I'm sure our.
I'll keep it cool.
Yeah, no, it's really exciting to have you back on. I think last time was it one of the game shows?
It was a game show, yeah.
Yeah, a feud episode, I think.
Those are fun and embarrassing. You watch it again and you're just like, why can't you just say the right answer, dork? And you're like, well, because I'm in the moment and it's hard. Yeah. So.
Yeah, I still can't get over not being able to name a browser. It's pretty bad.
Brains, they fart. You know, what are you going to do? I don't know.
But we're not here to talk about that today. We're here to talk about color. And there is a lot of wild things that we can do with color nowadays with just like pure CSS. I think. I mean, that's what you're going to tell us, right?
Yeah, well, and JavaScript. So like if you're a JS person that's just like, I love objects and calling functions and manipulating data, you're just like, cool, do you like color? Because color is totally like that. You're like, color's not. No, dude, I'm serious. Like color is totally a really fun object to play with in JavaScript, just as much as dates. I don't know if actually dates are fun. Money. You know, like there's like these rich, I know, yeah, those suck. Color's way more fun and it gives you something to see. So as you do all these things, you can show it and it's not just like dollar went up, you know, like you get to see like a color change and it's fun. Anyway, yeah.
I'm sold.
Yeah, same. Couldn't have said it better. So why don't you catch us up on where we're at? Because when I think of color, there's a couple of things. There is hex or RGB or RGBA. Are pretty much the main ones that I use. There's also HSL and HSLA, which I've also used, and IQ, saturation, and something. That's about the extent of my color knowledge. So can you enlighten me a little more?
Yeah, and you are not alone. We look at the like almanac data, and there's like nobody even using HSL. They're all it's like hex all day. Maybe some RGBA, which by the way, RGBA is dead. HSLA. Dead. It's now just HSL or RGB and you put a little slash at the end and you can put your percentage there. You don't have to change the function you're calling anymore just to add some alpha because y'all know that was so annoying anyway. Anyway, so yeah.
Wait, I had no idea. I saw some syntax like that with like a slash in there. I was like, why are they dividing in the middle of this?
It's like a classic CSS thing. There's slashes in border radius. There's slashes. Anyway, they're like to denote a break in sort of the parsing. Anyway, yeah, Amelia, where are you at with color? I want to know where your baseline is too, and we'll work up from there.
Oh, I'm still using color names like pink, sky blue. There's tomato red is a good one. There's cornflower blue. These are my top hits. That's where I'm most comfortable.
Those are awesome. All right, so few fun things about those. So the named colors are really fun to prototype with, and they have a fun attribute. Many of them, like deep pink. I really like deep pink because it's so hot. And if you look on your color picker, when you put deep pink in there and you pop it open, the little dot is in the far top right of the color square, and you're like, yeah, give me that brightest, most saturated color, you know, and that is the brightest hot pink that can be found in sRGB, which is standard dynamic range. So this is okay. We'll like roll this into kind of what we're talking about today is all these colors on the web have been SDR, standard dynamic range. And what we're getting and what we've gained is HDR colors, high dynamic range. So all these TVs you buy, your iPhones, your laptops, all these things all have millions and billions of colors. And you're like, right on, but then everything's using them, like the movies you're watching, the images you're looking at. Oh, come on, take a picture with an iPhone or an Android Pixel and you're like, look at the colors and you're like, that sunset is popping. Like there are definitely some like high dynamic range colors coming off that image. And so when you're using these named colors and hex and stuff, you're literally trapped to a tiny portion of what your screen is capable of doing. And so what CSS has done is graduated into the HDR space with a whole bunch of features that allow you as authors to take your website from an SDR website to an HDR website. And that is a product excellence thing. This is why Apple was first. They've had Display P3. This is a wide gamut color range since 2016 in all their products. And it makes sense. You look at an iPad in the App Store, you look at an iPad in an app, and you're like, the colors on this are beautiful. And they know that. They know that a user can't really articulate why, but they will tell you one looks better than the other. So there's an opportunity now for your brand to do this, or your colors, or whatever it is that you're building, to kind of reach into this HDR space. And then there's all sorts of goodies for us to talk about, like color manipulation. How do you specify colors? There's way more than HSL now, so I'm sorry, it kind of gets more confusing. It goes into gradients, it goes into animations, and we got all that stuff to talk about today. So how's that for a high-level little intro?
I have questions.
Yeah, me too.
Good. I'm here for you.
First off, you mentioned like all of those named color values, like I forgot, deep pink. Is that the one that you were talking about? Do those map to like the standard like 6 character RGB values?
Yep.
And is there a name for every combination of 6 character hex values?
Nope. They originally, I don't remember the year, who cares, but they're basically the box of crayons. Someone was like, oh, we got remember WebSafe, 256 colors? That's all you had to choose from. A lot of those are from the crayon box.
Okay.
Because that's how creative they were when they were writing the spec. Which, who cares? Those are good colors. So they like, a lot of those are crayon names, and those are RGB colors. Well, they're sRGB colors, and they are inside that space. So yeah, they literally map to an RGB color. They literally map to a hex, to an HSL. All of these color formats that we've been using today, even HWB, they're all in the sRGB range. They're in SDR, Standard Dynamic Range Color Space colors. So we've had all these ways to reference colors, but they're all from the same pool. And now we have new pools to specify colors from.
So my like 2002 knowledge on those colors was always like, oh, you shouldn't use those because they could, like, deep pink could be this on a Mac and this other value on a Windows machine. Is that the case now still, or have they kind of standardized?
They standardized. So what's cool about RGB and why RGB has been around for 25, 30 years is it is a common denominator. Basically, it's the most common junk that you can find everywhere. And everybody has united on this is a healthy baseline. It's not junk, let's be honest. Like, it's pretty good. This is why it's survived so long. And we're really only kind of getting nitpicky about bringing them into this HDR color space. And we were waiting for displays. There wasn't a whole lot of displays that could even show these colors until 5 or 7 years ago. So we're on this cusp where the capability is there, the math is there even for like downplaying some of these colors. So if I ask for some super rad new HDR color on a display that's 20 years old, the display is going to be like, I don't know what to do, but it'll show deep pink. Let's say I ask for deepest pink, whatever, like go into the crevices of the pool. The browser and the operating system and the display will all work together to go, well, my color profile and my capabilities say I can only go here, so I can only reach into this amount of RGB brightness in my little lights that I light up. And you're like, cool, just give me the maximum pink. I don't really care. But yeah, there's also media queries to help you handhold this. So let's say you don't want to let the browser and the operating system find something. You can be like, okay, well, hey, I'll give you a hex value. And then if it's an HDR capable display, which is the media query at media dynamic range high, then you can say inside of there, then bump up those colors, baby. We're going to disco town, or whatever it is that you're trying to do.
Okay, here's my biggest question. As a web developer, I have a healthy dose of fear of new things, right? And I want to know what % of displays people are using can go to disco town, right? Like, is this something only 10% of people are going to be able to use? or C?
Yes, that's a great question. Like a metric on how common or uncommon are HD displays.
Yeah.
This is going to be hard. It's like probably depends on your circles. I mean, every iPhone and every Mac is capable. So there's a percentage value for you already. Many Windows laptops are capable. You can go into the operating system of Windows and say, I want HDR Windows. And Windows will be like, all right, I'm going to start using HDR colors where I can. And all those little accent colors you get, they're going to be Disco Town. I like that we're calling them Disco Town colors. Let's hang on to that. I was just watching Lego Masters and that someone did like a disco scene, and now I guess that's why it's stuck in my head. But yeah, you're right. Like a lot of Android phones, just a lot of other devices don't have it. But where you find it's really common is the TVs people buy. It's like they don't even sell SDR TVs anymore. You can only get QHD, super duper, and there's like super high res ones. And then you have like your OLEDs, which are different because they can turn off the lights to make black, which is another thing. So a lot of these HDR colors, one aspect of them is how black of a black can you make and how white of a white can you make. This is like the nits that you'll read. You go look at a brand new Mac laptop and they're gonna be like 10,000 nits. And you're like, what do I need? I don't know how many nits do I need, you know, like, and they're like, well, you want the most nits because it's a couple $100 extra, you know, and you're like, I don't know. So anyway, that's kind of like some of the factors that are in there. I think it's a lot more common now than we think. And I think that's why the timing is really good now. Another like weird little niche detail here is that the web has been capable of HDR in images and videos for many years, just not from CSS.
Interesting. So how do you enable it in CSS? It's got to be more than RGB or those hex colors, right?
You have to use a new function to specify the colors. You have to ask for a color from a new pool. And so that's kind of what these color spaces are. They're new pools, new opportunities, more range, which also means things like gradients have less banding because, here was another reason that like CSS was kind of slow to this is a lot of the browser engines were like, hey, sRGB's been really hex. That only takes a little bit of memory to hold the values for that. And these new ones, they require double and maybe triple the memory. So we're going to kind of wait on that because we don't want to double every color in the whole system. And there was like this fear about how impactful storing just the values of these colors in memory was going to be. And some genius was just like a few years ago was like, how about we only double if it's in the new range, then if the site doesn't use any HD colors, we don't change the memory. And everyone's like, why? We'd never thought of that. And so all of a sudden it became like really viable to just in time upgrade colors to a bigger memory allocation if needed. So yeah, types, dude, types. It was literally a type issue. Oh, also, by the way, colors.
Did you say types?
I did say types. And dude, all colors in CSS are typed, dude. And they are typed well. Very intricately typed. It's a typed system from the top to the bottom, man. You call functions, you pass parameters, they're all typed. The ins are typed, the outs are typed. It is really cool. So anyway, if you like types, the new color stuff it's very interesting. Yeah.
My mind is blown.
He's hooked.
Is it like types in CSS then? Or
dude, CSS has always been typed, bro. It's typed and it's resilient. So it has this like thing where if you put the wrong value into somewhere, CSS doesn't crumble and go, oh no, there's one little wrong thing in my entire application. I can't even do anything, which is what TypeScript does. Sorry. That's what all type languages do, really. It's a good reason. I know, but it doesn't have to stop the show. CSS doesn't stop the show. CSS goes, oh, that's wrong. Yeah, whatever. And it just keeps going. And so you can pass, for example, you could pass pixels to something that needed a color type. And it would be like, all right, well, nice try. And it would just roll on, right? But it is a type. So that's how they have type validation is it knows if a length or if a type and what all. Anyway, so it's all typed. It always has been. It's just sort of lesser known because it's not strict about it.
So I don't know how things work in your neck of the woods, but if you put something into CSS and it's wrong, but it doesn't care and it just stays there, that is now part of the legacy of the app that I'm working on. Like nobody goes back and cleans that up. Yes.
Seriously, I just learned about how many to-dos are in the Google code base.
Oh no.
Oh no.
It's insane. I was like, oh, surely it's just a couple. No, dude, it's so many to-dos. And you're just like, but those are just left hanging. Yeah, that's software. We can't get to every edge case and everything all the time. It's gnarly. Anyway, that's a rant.
I think to-dos are they're just performance art, right? You leave them there, you're like, I know I'm supposed to do this. I just want you to know that I know.
Funny.
I'm not gonna.
So yeah, there's a little mind-blown color stuff. Yeah, where do you want to go next?
Well, so you mentioned that it's a new function. What does that actually look like to access these new colors?
Awesome question. Okay, so let's start with the most supported one, or the one that's historically has support, is the color function. So it's literally, you call color, you pass in, you got 2 parentheses, and the first parameter is the color space. And the one that Apple has supported for about 6 or 7 years is the display P3 color space. So you say color, open parentheses, display -P3, space, and then you pass 3 channel amounts. And so it's basically asking for brightness from 0% to 100%, saying how much power should the display put behind those RGB lights that it's going to light up for this color. And you can say 100%, 0 and 100%, or you could say 101. So CSS is very good about understanding a range between 0 and 1 and 0 and 100%. So it's on you as an author to kind of pick how you like to work inside of there. And it's as simple as that. So you say like background is color, open parentheses, display P3, 101, end parentheses, and you got yourself a super hot pink because you maximized the R and the B and you left the G. I can't believe I did that in my head. Wow.
Yeah.
Okay, that was pretty good.
That was going to be my next question is like the percentages, was that R, G, and B that you're...
It was R, G, and B. So that's another thing. That's why the RGBA function here, yeah, let's just like retract a little bit. RGBA was dropped not just because of convenience, because it was really, truly annoying. Like you're like, I need to add alpha. You're like, dang, I have to call a different function. It's really annoying. So what they did is they also normalized that all these functions take 3 channels. Hex is kind of the odd one out here in that it represents the 3 channels, right? In like a hexadecimal. And now it's just very blunt. It's like, here's 3 channels. And so moving forward, every one of these color spaces is 3 channels. And then you have your alpha with the slash. And so it's kind of nice. If you're used to HSL, there's a new one called LCH, which is kind of almost like the same letters in a new arrangement. It's kind of annoying. And then there's even one called OK LCH, which is superior to LCH, even though it makes it sound marginally better or marginally compared. Anyway, it's like the person that came up with OK LCH was just really humble about it. They could have been like rad LCH or, like dopeness LCH, but they were like, it's okay. And you're like, well, you really sold that short because it's really good. And the OK LCH color function, so instead of calling the color function, like we did earlier, you can just reference the color space exactly in a function. You say OK LCH, just like you did with HSL, open up a parentheses, pass 3 channels, and L is your lightness. Well, it's who cares? It gets more technical than that, but you got an L that's perceptual lightness. This is lightness per your eyes as a human, whereas HSL was lightness in math, which is not, they're just not the same. So then you have C and H. C is chroma and H is hue. So your hues are pretty similar. Your chroma is about like how much vibrance. It's kind of like saturation, but it's a little bit different. So anyway, each of these color spaces are really unique in that they bring something different to the table. They're like a utility function that you can call to get access to colors in a way that is optimized for one thing over another. And so you kind of learn these, but OKLCH is a really good first place to start because it both can go into super wide gamut HDR colors, but it also has a really, really reliable lightness channel that makes it great for design systems, makes it great for lightness adjustments, and then color functions. Like if you want to manipulate a color, like darken or lighten something, it has reliable results. And so, yeah, there's like a little, so there's how you access the colors. You call these new functions, you either call the color function and pass a color space, or you call the color space itself directly, like OKLCH or lab or LCH.
Do you find yourself itching to grow at work, but you're not getting the support you need from your manager? Or maybe you're at a career transition and trying to figure out what you want and how to get it. Or you've got a great job, but could use an external perspective on some tricky cross-functional relationships. Hi, this is K-Ball from JS Party, and these are the exact types of problems I'm helping folks with in my new business. I think about it as pair programming for non-technical problems. If you're curious, you can learn more and sign up for a free exploratory session at kball.llc/coaching.
Okay, here's the question I've been wondering since you said the word gradient.
Yes.
And I've never thought about this before, but if you define the, like, say the start and the end color for a gradient in a different color space, will it interpolate differently, or is it only for the way you're defining those colors?
This is such a good question. It does interpolate differently. Wow. This is where we could even pull up a quick little visual. Like, I know you've seen the RGB cube, right? All the colors packed so nicely into a cube. And then imagine you put two little points in there in a three-dimensional space, and that's your gradient points. And then the cube and your function have to go from one to the next. And it literally goes in a straight line because that's what math does, right? It goes straight from one color to the next, which means it's going to go through the middle of the cube, or it's going to go through different parts of the cube that gather the way that the gradient looks at the end. HSL is a cylinder. So again, as you make a gradient in it, you get a different result because the path that it took, like literally like a journey, you could be like, this is fun. Let's make a metaphor out of this. This is a video game. You got like a journey, different mountains that you have to cross. And like your little journey person starts here at color 1 and then you have color 2. And depending on the mountain, they take a different path to get there. And as they go, they collect little colors. And then in the end, you get a whole range of the colors that they went through.
Man, I'd play that.
Yeah, that kind of sounds cool. Yeah, I agree. And that's color interpolation. And you can also do this with animation. If you animate from blue to white, it's the same concept. Instead of you seeing one smear of the color from blue to white, like a gradient does, you see it change step by step over time. So you only see one state of the color interpolation over time. And so, yeah, each color space has different results. That's why new gradients use the OKLab color space by default, because it is optimized for vibrance and avoiding the dead zone, which is what RGB has notoriously. When you go through that middle space, the middle is white. And so you pick up lighter colors on your way. Sometimes they look gray or muddy. And these new color spaces create gradients that are much more vibrant and don't have the muddy zone because they're packed different, so that when the little journeyman travels across the mountain, he stays in the bright areas.
I like that metaphor or analogy. So you can't define a gradient with two different color spaces. I've never tried it.
That is correct. You can, it will interpolate in one color space, but you can put colors from two. This is a great, like, mind-blowing question. So you've got like color number 1 is hex something, right? You're like SDR color. And then the other color is OKLCH, something turbo rad cyan. The browser, there's math in the CSS specs on how to resolve that. And so they're going to get put into a color space that is big enough that they both can share a position in it. And then they're going to get converted into the color space that the interpolation happens in, and then the interpolation happens. So there's a conversion and then interpolation. And yeah, so this is, again, color gets really, really complex really fast. I'm going to hope to make this sound as simple as possible throughout this podcast episode. But this is, again, why it's kind of like working with dates or working with money. There's a lot that can happen in the math between conversion and interpolation and yeah, it's all math. In the end result, you see a color, though.
I love that. Also, so you mentioned JavaScript, right? Where does JavaScript come into play here? Or are we only working in CSS here?
Yeah, that's a good question. CSS has easy access to all these functions, but from JavaScript, you can set colors, you can extract colors. Eventually, there's going to be an object model for it, so that you'll get a rich object back that has the channels already broken out for you into RGB or LCH and stuff like that. At which point you'll be able to destructure a color. Oh, okay, I will have to move into the RCS next, the relative color syntax, because you literally destructure a color in CSS, put it back together in one line of code, and then return it to the browser. It's super rad. But in JavaScript, you could do that now. You could grab a color off an element. You could split it by space and find your channels, reassemble it, put it all back together after some math, and put it back in. There's also a lot of color libraries to work with. There's many of them. The folks that wrote the specs Leah Veru and Chris Lilly have one called Color.js. I use it all the time, and that's very spec compliant for CSS, and you get this really rich experience working with color from JavaScript. It's super fun, and you can make gradients and various color spaces. I have all sorts of cool demos I'll share at some point. Oh, here, I think I have a CodePen collection of color stuff. Let me send this to you. And it's a mix of CSS and JavaScript, HD color and color functions. Here, put this in the JS Party chat. Boop.
We will include that in the show notes as well.
And yeah, a lot of this stuff there's tons of utility in each color space. There's utility in knowing the JavaScript ways and the CSS, just like normal web development, right? You have like this harmony and a relationship and an orchestration that you're going to find the best tool for the job. And these new color spaces give you better tools for the job. So that's kind of what's nice is after this podcast, you're going to be like, I have new color tools that help me perform my work better. I like literally learned new functions that give me better results than what I've been working with in the past.
Yeah, that's awesome. And I love that the fallback is pretty simple, right? Like I get really nervous with new tech on the web because I don't know what's going to happen when a browser doesn't have access to it or doesn't support it.
Yeah, it's a good concern. There's a few ways to handle like upgrading. So you could progressively enhance. So you've already got an app. Mm-hmm. It's already got colors. You've got bright blue, bright yellow somewhere in the app. And then you could easily say app media, dynamic range is high, target those colors, those custom properties or whatever, and use OKLCH and bump them up. And now all your yellows and blues are bumped up in a safe way. There's actually an additional query that you can put in there because there's a difference between the display having the capability and the browser being able to parse. And so you can also put in an @supports parsing function in there. It says, hey, do you even understand display P3? Do you even understand OKLCH? I don't want to give you this color unless you can. So you can be really hand-holdy with like 2 media queries, or you can just do the cascade. You just drop it in the cascade and just like, hey, here's the color one is hot pink, and then next one is hot pink and OKLCH. And if the browser doesn't know what OKLCH is, it goes, cool, I don't know what it is. I'll throw it away. I'll just take the color I got before then. And there's even another way that you can do this, an even lazier way, which is you just use the new color functions. And if the browser doesn't understand it, well, you wouldn't get a color, so that'd be the bummer. But if it does understand it, it will automatically adjust it for the display and the capabilities of the device. So you can be like, I'm just going to use these new colors, and I'll let the browser and the display and the operating system work out how rich it can make this pink, how rich it can make that blue. So you have all of these options. You have graceful degradation, you have progressive enhancement, you have lazy, I'm just going to let it be broken on other stuff if I want. Yeah, it's all there for you.
Speaking of broken on other stuff, I was looking up OKLCH in MDN, and it looks like Firefox is the only one that doesn't support it right now.
Yeah, and that recently merged. They'll have it,
okay.
And so it's in nightly, and it'll be in Firefox stable, I think that 1.14 or something like that. I don't remember the exact version, but it's soon. Nice.
So I'm confused. I guess the part that's confusing me a little bit is like, if you were going to create a new site and you wanted, you're creating a design for it, are you primarily playing within the standard range colors, or like would you have like your primary and secondary colors being in this higher dynamic range with fallbacks into that? Like when do you use what? And can you rely on, I don't know. I'm confused about like, if Adam is starting a site, are you primarily still using RGB in a lot of places, or are you dipping into this OKLCH and these new color functions?
Super good question. And I'll answer it in kind of 2 parts. I just redid my website, nerdy.dev. Have fun, check it out. It does use HDR colors, but it upgrades to them. And so I'm using the approach that I mentioned earlier with a media query, checking to see if the display is capable and checking to see if it understands the parsing. That way I safely upgrade any vibrant colors. Like the syntax highlighting is using HDR colors. Anywhere where we see a nice bright color, especially in the dark mode got a lot more treatment for the neons that you can get out of these HDR colors. The other side of this, though, is that's Adam doing his own design I don't know, third person is always so weird. That's me. That's me wearing both hats, right? I like a designer hat and a developer hat, and I know what I'm doing. Now, designers, though, like on teams that I've always been in, they live in ideal land, right? They always make ideal comps with ideal layouts, with ideal users. The user really takes great pictures. Look at that. Look at that profile page. It's amazing. And then you go to the actual app and you're like, oh, that user's pictures suck. Anyway, so like designers are supposed to live in this ideal space, at least in the beginning of the app. Who cares? But anyway, they should be using HD colors, in my opinion, there. The bummer is a lot of the design tools haven't really caught up. It takes, I'd say, 10% or 15% of the designers that I know even know this stuff exists, and their work is better because of it. But it's just not popular, or I don't know, we're still catching up. I think it's, like people still don't even realize why they bought a UHD TV. They don't even know what they bought. They're like, I bought a new TV. You're like, how many colors does it have? And they're like, I don't know, a lot. And you're like, that's fine. Like I don't expect everyone to know that. I didn't even really know it before. But I think as designers want product excellence and they live in the ideal state, they should be using the ideal colors, which again, they manipulate better. Like you want to make a light variant, it lightens better in OKLCH. It just does. HSL can do funky stuff. And so they'll eventually be working in these, you'll be inheriting them, and the relationship will change, at which point you'll be producing fallbacks at some point, or no fallbacks at all as we move forward into 2024 and just like everything's HDR or whatever. But yeah, I feel like I went on 2 tangents, and I hope I answered your question.
Yeah, I think so. So in 2024 and beyond, when all of this is fully supported in every browser and works great, is there a use case for the older color syntaxes?
I mean, I have friends that work on LCD panels or like kiosks or all sorts of like interesting niche industry software on weird screens. No, they're still going to be in SDR land because RGB is just so ubiquitous in that way. But I think as we look for product excellence and we want to use the features that someone's got in their hand, like a device that's like HDR capable, you're going to want to give them that color quality. It will look and feel different. Mm-hmm. So yeah, I think our expectations as users might change a little bit as we get there.
Well, I have the opposite question to what you just asked, Nick. So what's like the best case scenario, right? We use these and like colors pop more, gradients interpolate better. Like what are we getting from this? And also, does it matter evenly across colors, right? Like is pink way deeper than RGB pink, but yellow is kind of the same?
Nice. Cool. Okay, 2 parts. The second part is easier to answer is that, yeah, some of these new color spaces offer way more blues than they do yellows. Like, for example, yellow is tough. Every color space has like a tiny amount of yellow to choose from. Whereas blues and greens and pinks and reds, they just go crazy, which is also because that's how our eyes are. Our eyes are like super attuned to some of these colors more than others. And anyway, it's also the shape of the space, but yes, some hues do offer more than other hues. The first part of the question though is, what is like the main benefit here? It's vibrancy, it's design system consistency. So I have like some demos I can share with you that where I've defined 15 custom properties in OKLCH, and you can just change the hue and you get a perfect palette in any hue that you want. So you don't have to download the Tailwind blue, or you don't have to download, like my library, open props pink, and you don't have to grab pink and green or whatever. You don't have to go pick. You just grab 15 props and change the hue. You can also adjust the chroma. So if you want a more vibrant color palette, you bump up the chroma. If you want it more pastel-y, you drop the chroma. So with 15 props, you literally have hundreds and thousands of color palettes to choose from versus the way that we're working today with RGB, where we sort of prefix these, 9 or 12 or 15 colors, and then we try to work within that set. We can do the same thing with 15 props and make it adaptive and dynamic for light and dark and all this sort of stuff. So yeah, you get design systems, vibrancy, manipulation consistency. Oh, and the gradients are better. The gradients do genuinely look better. And that's why you've even seen, I don't know if you've seen the tools that, like Eric Kennedy has a tool where you go and make a gradient on his tool, and the output, you put 2 color stops in, and the output is 8 stops. And the reason that he does that is he literally has written an algorithm to avoid the dead zone by hand holding the gradient, adding additional stops so that it never goes through the center. It's like giving the journeyman more positions on the mountain to avoid the spots that are dangerous. Hey, that actually worked out pretty good.
That's sweet.
So you have like some of these things. It's gonna be smoothness, vibrance, excellence, consistency, and reliability of manipulation. Them, yeah. But it is more confusing in a way. Like I totally empathize with how heavy this stuff can sound, and that's why I'm like keep asking the basic questions over and over, because everyone who's listening is gonna have the same questions, y'all. And don't feel bad. This crap is somehow confusing. You're like, color is supposed to be simple, and you're like, all of a sudden it's not, and you're like, well, coding is like that all the time, but yeah.
Well, good. I'm glad you're giving me permission, because I'm going to keep going.
Yeah,
I'm trying to understand, and I'm already terrible at this stuff, but I'm terrible with RGB, and there's just so much more. But a question I had was, so like this OKLCH thing, going back to that a little bit, you said that it's defined. It now works in every browser, Firefox, all of that. And I create a site and use that completely. But then here I am on a nice modern Mac, but I'm using a really old, really cheap display with it that doesn't support all of that.
Yeah.
Does that, like, if I defined like some neon blue that's very vibrant, will that get translated into a more muted blue by my display and still show up as some kind of blue, or what happens there?
Yes. So yeah, this display I'm looking at right now that y'all are on is a poopy SDR display. It's cheap and whatever. The one I have over here, this is my Mac one. It's very nice. I can literally take a tab from Chrome or Safari and drag it over and watch them go boop and get like downgraded. But here's the thing, just like we were talking about deep pink or the named system colors, and those are reaching into the furthest corner that's capable in that SDR RGB color space. That's all the display in the operating system is going to do when you ask for super rad, disco pink. When you bring it onto a monitor that can't do it, the operating system and the browser, they all orchestrate and go, hey, look, this display can't do that. You got to downplay it, and it'll automatically downplay it into the best pink that's possible. So that's kind of what's nice, is you're reaching really far, and most of the displays won't be able to do even some of the stuff OKLCH can do, but it will do the best it can. And that's kind of one of the fun parts here, is you're asking everybody's device to do the best pink that it can, the best vibrant thing that it's possible, and you just let it adapt to all these scenarios, just like a width of text, just like a lot of our responsive design and our adaptive design is doing, where we don't nitpick and pixel perfect everything. The same thing's going to happen with color, where someone over here is going to have a regular display, someone over here is going to have a super one, and both their displays are doing the best they can with OKLCH. Yeah. There's a cool site you can go to, oklch.com. It's made by Evil Martians, the post-CSS folks. Well, they work on post-CSS and they do lots of other stuff, but it's a very good site. It's also going to immediately be annoying and confusing if you don't do much color stuff, because you're going to be like, oh, look, charts that I don't know what they mean. But at the same time, it gives you a really good gauge. Like there's going to be two switches there, one's for P3 and one's for Rec 2020. And you should turn on Rec 2020 just to see the additional lines that you get. There's going to be cutoffs. And the cutoffs are going to tell you how dynamic is this color. And you can choose to, reach really far into Rec 2020. And it'll even show you the fallbacks. So it has that little, like in the top left there, it'll say, here's the color you're building. Here's what that looks like in sRGB. And you get like a comparison. And that tool is really nice for seeing how the color space OKLCH has some quirks. You'll see these curves and these cuts. And then if you're looking for super bright, vibrant, you can use their controls to find that peak color that's in there and then put it in your code. And it helps you create OKLCH values as like an OKLCH color picker.
What is Rec 2020?
Rec 2020? Yeah, so let's talk about sizes of like sports balls. You've got like a baseball, which is your current hex and sRGB color size. All the colors that it can do fit inside of a baseball. Then you have display P3. Let's imagine it's a softball, maybe. Yeah, it's a softball. Sure, you get like 40% more colors or something like that with display P3. So you literally have these two in your hand, and there's literally more colors in the bigger sized sports ball. And then you have like a basketball, which is Rec 2020. So Rec 2020 is it's recommendation, and it was recommended in 2020 for like super, like what's the movie theaters we go to that are like crazy rad? IMAX. Yes, so you got like IMAX colors. These are the folks that are like real, okay, and then, okay, here's another one. Who's the director that did Avatar and stuff? Whatever. Okay, anyway, like this person's using a camera that's like recording really rad colors at the super raddest maximum that 2020 could do, right? That's Rec 2020. It's a standard space where all these things that are capturing and intaking color can put them into a space that everybody agrees on, and then they know what size that is. Which, by the way, sRGB, P3, and Rec 2020 are gamuts. And that's why I referenced a size of a ball, like a volume, because you have different volumes of colors. But remember, in the gamut of sRGB, like the baseball, you have HSL, hex, HWB, and all these different ways to access colors from the same pool, but in a different shape. This is where things, I'm sorry, this stuff gets trippy. But you have pools of colors, like total number of colors, and that's your gamut. And then the color space is a shape. And you think about like the RGB cube. The RGB cube is showing you both its shape and its gamut in one view. But you can separate them. You abstract them into two different types, two different data representations, one just being a totality and the other one being a shape meant for purpose. The HSL cylinder is very handy because we think about color in a wheel. You got that circle, you can just easily change the hue. And as you go down the cylinder, you get darker. And as you go up the cylinder, you get lighter. So it made sense for people to interact with HSL in a very reasonable, humanistic way. They think about a hue, they change the brightness, and then they change the lightness. And so these new color spaces like OKLCH operate in the same sort of accessing language where you still say, I want a hue and I want some brightness and I want some lightness to change, but the shape of it is drastically different. And so these color spaces, each shape has a superpower. That's why there's no one true shape right now. There's no one true color space. And OKLCH just came out like a couple years ago. It's crazy. It like literally, so inventions will happen. We are not done with color. Color is, we haven't reached, our displays haven't reached what our human eyes can do yet. The code that we write hasn't reached into, it doesn't have access to all this stuff yet. We haven't found the perfect shape that represents the possibility of the gamut, what the handiness of using it. Like there's problems with the OKLCH, even though it's the best one we have. There's issues in it, and people that study it know it. They're trying to solve it. There's like schools of study trying to fix and create the next best color space. It's very computer sciencey, very heavy into math and 3 dimensions and plotting. It's crazy. It's like a totally deep world that spans media. It spans the movie industry. It spans the photography industry. And now it's in CSS where we're getting the capabilities that they've had for a number of years. It's
a whole new world out there. Do you have any like tangible explanations for what's changed for monitors? Like the hardware aspect, right? Like how are we bumping up the colors that we can represent within our monitors?
Yeah, that's a good question. One of the best examples is what I was talking about earlier. I think it's UHD or no, it's OLED. OLED is more expensive because you know, like we have like Black Mirror. You know, when your TV is off, it's literally black and it's like reflectively black. But if you turn it on and it's broken, it's dark gray. That's not OLED. That's your RGB lights at the lowest setting that they have. And it's just like, but that's not a rich black color, which means if you're watching Game of Thrones, which I watch Game of Thrones on my crappy TVs all the time, and I get tons of bad color because they're so dark in a scene and my screen can't do it, that I see these like bands of gray. When I know the reality is if I was on an OLED display with a really, really rich amount of dark range in it, I would see richness there, and there would be millions, maybe more colors just in the dark area, let alone the light area where the whites are better because of the nits. Nits come down to the power of the lights. How powerful can these things combine to create a white? There's literally whiter whites. And I know we talk about that like painting your home. You know, like, oh, there's 10 whites to choose from painting the walls. You're like, there's 10 whites? Come on. And then you see them all together. You're like, oh, crap, I see the difference. That's annoying. Same thing happens with the display and nits. You get more whites. The whites are whiter, and it makes a difference. Having that darker dark and the lighter lights, as well as a bigger gamut of colors. Now you're watching Discovery Planet and really getting immersed, right? You're like, well, the waves are crashing. That's good stuff. So there's like some background on like the displays and the capabilities that are changing, that are enabling these things to be in our homes and our pockets.
So that makes sense for like the blacks and the whites, right? The blacks they can turn the pixels off effectively, or eliminate or reduce the glare from other pixels close by maybe. And then the nits for whiteness. But for when it's actually like showing color, is it still just RGB colors that it's like RGB LEDs that it's putting together? And is there just more of them to allow it to?
That I don't know. I'm assuming more powerful. And then the color space, it's just the math that's built into the hardware is able to do the sub-pixel, well, it's not sub-pixel, but like floats. You know how float values, and those might not have been able to be done with older TVs. They didn't have the compute power, and now we have the compute power, so they're doing the float numbers, and so they're getting micro adjusted in the water, which is why you get possibly 1 million more blues in between 2 other blues. It gets really heavy. Yeah.
So we have like, are the extra colors, are they evenly dispersed throughout the luminance, or like do we have more just like brighter, like do we get brighter colors, or we get more colors like evenly throughout the spectrum?
Excellent question. So if you think about the gamuts are the totality of colors possible. So if you're in the P3 color space, there's a certain number of colors that it says, I can do this. If you're P3 gamut compliant, it means you can represent everything inside of there. And it's just like flattened out kind of, and you get this view that doesn't feel very dispersed. It looks very evenly distributed. But when you get into the color spaces where you change the shape of something, the shape change can heavily impact how many you have there. But okay, so let's talk about like OKLCH. If you're in the red hue and you go from lightness 100 to lightness 0, this is a superpower of LCH and OKLCH. These are called CIE lab color spaces. They're perceptually uniform for human vision. They were tested in the 70s, and they got tons of participants to say what was lighter or what was darker, and they arranged a color space based on how we see, so that it doesn't matter what hue you're in. You do get an even distribution from 0 to 100%. This is why it's a powerful space for a design system, is if you want to lighten or darken a color, you're literally lightening or darkening it based on the way that our eyes perceive color, the noticeable difference that the human eye can see, not the change in a number in a mathematical color space shape, but literally something that 1% will change something visually 1% to humans. And so that's something special for that color space. Other color spaces might not be that way. I did want to mention one more thing too, is sometimes it can sound like when I'm talking about this stuff, like RGB is somehow not capable, or RGB, like the lights aren't, or just like the color concept of 3 channels that way is not good. It's very good. There's color spaces that use RGB that are very HDR. There's Adobe Pro Photo is a very wide gamut RGB based color space. And even Rec 2020 has an RGB mode where you can access colors using R, G, and B, because so many of our displays display color that way. So we can specify, how much power to put on each of those lights. But yeah, I know this stuff gets gnar. To bring it back to CSS a little bit though, like want to chat about like some color functions, so we'll go beyond color spaces and gamuts and kind of chat about like usage and stuff that you might do inside your application that's handy, and how SAS helped and how SAS is adapted to the changes in CSS as well.
Yes, I wanted to ask about this.
Unless there's more questions, but yeah.
No, let's do that.
Cool. Okay, so in SAS, you've had darken and lighten for a long time. Those were always done in the color space that they knew best, which was sRGB. They've changed it. Now, actually, they didn't change it, but they did. Do you remember when they stopped saying use lighten and darken? They said use color adjust.
Didn't get that memo.
Yeah, a lot of people didn't get the memo. They gave that memo because people were really realizing that darken and lighten would sometimes give them weird results. And so color adjust was used to do the same work with a very similar syntax, but in a better color space, so that the results weren't so weird. So now we have CSS, which can lighten and darken colors. And so there's 2 different ways to do it. One has great support and one is on its way. The great support method is the color mix function. You call the color mix function, you pass 2 colors. You can say which color space to mix them in, and you'll get an output result of them. You can mix a color with transparency, so to make a color more or less transparent. You can mix a color with white to lighten it, if you want to lighten it in a sort of like mixing fashion. And you can darken things by mixing it with black or another darker version of the hue. And that's color mix. It's kind of, a little basic in its way, because it only, but there's also one called relative color syntax, which allows you to, so let's say you have a brand color that's like pound F 10 or whatever, right? This is again like a designer give you a hex color and you need to do manipulations on it. You can now say color. So we're going to use the color function like we were talking about earlier with display P3. Color, open parentheses, from your hex color. And when you say color from, well, you can even say like OKLCH from, you're going to get back a destructured version of that color in the color space that you asked for it. So you could say HSL from hex and you'd get HS and L back. You could say OKLCH from hex and you would get LCH back. And when you get those values, you can use the calc function to increase or decrease them or divide them or multiply them. So you could double the amount of saturation. You could divide the saturation. You could divide the lightness. You can also just squash it. So you could be like, hey, I got LCH back. I don't care about L. I want a really dark version of this color. And so you set L to 5% or something like that. Now you have a really dark version of that hex color. And so you're getting these new functions that allow you to very, very dynamically build out variants and derivative colors and like derive colors from other ones and build entire systems and entire palettes that are very robust and consistent. Again, if you're working inside of that LCH or OKLCH space, you're going to get that consistent lightness. So if a user chooses they want the theme to be green, they get a nice visually consistent green theme. If they change it to red, they're going to get something that's perceptually the same lightness across the board, just a different hue. And it turns out HSL does not have that power. It has a lot of oddities in terms of lightness. So yeah, relative color syntax, often called RCS, and the color mix function are here to save the day for mixing colors, making variants, and just doing overall color manipulation inside of CSS.
What the heck? CSS added all of these cool features and I didn't even notice. This is amazing.
Yeah, the sad thing too is like I'm Googling this stuff as you're like saying it, and I'm seeing all these like blog posts from 2021, and I'm like, wow, I just had no idea.
Where have I been?
Don't worry. If anything, everyone is probably in the same seat, sitting in their car listening to this episode going, I just still use hex. Well, I have news for y'all. This is the best time to ramp up. Skip HSL. Skip HWB. Go straight for OKLCH. If you want my recommendation right now, go straight to OKLCH and go start playing with it in the browser. Go see the colors that you can get from it, like maximize the chroma, change the lightness, and look to see how these things change, and go build a little color system with it. I also have convenience things. So you can, OpenProps has a couple of packs that are OKLCH packs ready for you to go, where you just import this one line. It's like OpenProps, like from Unpackage, and you get 15 OKLCH props from me that you can then go change the hue and the chroma of and get entirely new palettes in any hue and any color that you want. You can start playing with those right away. And I'll put those in the show notes too. It's cool stuff. It's a cool time to start switching. I think by 2024, we're going to see it, well supported in browsers, and it won't be an issue, and we'll be off to the races with wide gamut colors in our apps.
It is now time for a changelog news break. The team at Suno AI is helping change the game in text-to-speech realism by releasing Bark, a transformer-based text-to-audio model that can generate highly realistic multilingual speech as well as other audio, including music, background noise, and simple sound effects. It can also laugh, sigh, cry, and make other non-word sounds that people make. Crazy, right? Here's an example that includes sad and sighs meta tags.
My friend's bakery burned down last night. Now, his business is toast.
And here's one more with laughter.
I don't like PyTorch, Kubernetes, or Schnitzel. And xylophones flummox me.
You can still hear some digital artifacts and blips here and there, but we're getting closer to synthesized audio that's indistinguishable from the real thing. And that's cool/scary. You just heard one of our 5 top stories from Monday's Changelog News. Subscribe to the podcast to get all of the week's top stories and pop your email address in at changelog.com/news to also receive our free companion email with even more developer news worth your attention. Once again, that's changelog.com/news.
So that's a great segue into the question I wanted to ask, which is like, what's the support like for this within like design tools? Because like when I think of like, doing this, I usually get like a Figma design from our UX folks and I have to like translate that into the web somehow. And I'm looking at, the exact colors that they give me, and Figma's usually giving me, right now it's RGB or hex colors. So can these be defined in tools like that? Or should I go back to them and be like, I'm going to translate this to OKLCH and watch their faces melt like mine? Or like, what's the support like for that?
Yes, great question. So Photoshop has had lab in it, which is Scilab colors, kind of like LCH. It's been in there for years. People just don't use it. They're just very accustomed to poking inside the pool of RGB.
Yeah.
A lot of designers also pick colors from their heart. It's like a subjective thing. They're not there doing mathematical computations like we do in code. In code, we're like, no, I want to know is it 5%? And they're like, it's 5.25% darker. And you're like, I'm going to round it. I'm going to round that because it don't matter, and it makes my code look cleaner if I don't have the sub. Anyway, okay, so that was off the topic. Figma does not have support for these. You're right. It's stuck in sRGB. It's a SDR only. They target multi-platforms. They're not just web. They're not just Android. I'm in talks with them right now about trying to figure this out. I'm like, hey, these colors are better. The gradients are better. I know you like product excellence. I know that most of your targets are iOS and Android apps. Those are HDR spaces. And now the web is HDR. You can get HDR across the board now. Make that the common denominator and offer hex as an export option. Mm-hmm. There is a plugin that you can get in Figma. Adobe XD does not have wide gamut colors. Pretty much it's exclusively Photoshop right now. And then web tools. There's a bunch of web tools that'll help you make HD colors. But yeah, I'm very much in the same boat as you were. I'm like, if designers aren't handing these off to developers, it's probably not going to get done. Except for those, there's a lot of folks that spend a lot of time in design systems managing the colors of their application and building robust systems. They are going to be stoked on OKLCH and these color functions. They're going to get rid of all sorts of stuff. They're going to build it natively into their CSS, and they're going to get awesome results. So less code, better results. But yeah, until designers are handing it off, it's probably going to be a slow ball to get pushed up a hill. Yeah, so it could be on you to do it. And you could, honestly, I think a lot of we're going to see right now is some bottom-up education happening where developers are like, I got this new tool and look at these gradients. They're sick. And the designer's gonna be like, your gradients aren't better than mine. Your gradients are better than mine. You'll be like, yeah, let's talk about it. Let's get these in the app. Let's get, they look fresh. Anyway, so that's going to happen too. Speaking of gradients, can I share my tool? I want to announce a tool to help people. So I mentioned OKLCH.com, which is a phenomenal OKLCH color picker. I have been working for the past few months to help enable people into getting into these new color spaces, to learning and seeing what CSS Color can do, and especially seeing the results that you get in CSS gradients. You can now go to gradient.style. And that's where I'm building a very much, it looks like a design tool to help you build these new HDR gradients and see the SDR version fallback. So I'll generate a fallback gradient for you, and I generate the new modern gradient for you. You can change color spaces. You can do all this stuff, and it's really, really nice, really visual. And you can even drag it across from an SDR monitor to an HDR monitor and kind of see it that way as well, and just see the change and start to feel out these colors. I think there's two main things on that tool that are really fun to do. Well, there's a lot of main things to do, but the first one is use the color picker. So if you see a little color dot, that's one of your color stops, click it and you'll get the world's first next-gen CSS color picker, where it supports every color space that CSS supports. They're even grouped and tell you if they're HD or SDR and stuff like that, which is really nice. And they give you little controls to go play inside of there, and it will convert. So if you have a hex color, for example, you can paste a hex color into the color stop, open up the color picker, go to OKLCH, it will convert the hex to OKLCH, and then you can go bump the chroma up and be like, how much brighter can I make this hex? You'd be like, oh crap, that's a lot brighter. And you can do that. Another fun thing to do is to try on the gradients that are in the bottom left. There's some presets where I've created some things for you to go explore and try on. And then there's a Discord if you want to join and ask questions and learn more about color spaces and about CSS color. In the top right, there's a settings cog. Click that and go to, I think it's like help and feedback or something like that. And that'll pump you out to the Discord to come have conversations in there. There's also just above that is tips and tricks. And you can click that, and I put a bunch of hints all over the UI to help you learn about what the UI is doing and help you get you the ball rolling into building a new gradient in these new color spaces. Gradient.style. I'm going to probably be working on it till the end of the year. You can tell some of the stuff's not done. It's in beta, but it's a really strong place to start as we transition as an industry out of SDR, which we've been in for 25 years, into HDR, which is the future.
This is so cool. I've just been poking around and not listening to you, but if you're listening, you should go check it out. Also, you can set the hue path. Like you can do like longest path between two colors instead of the shortest.
Yes. Okay. So this
cool.
is such a cool one. It only works for cylindrical color spaces. So like HSL is a cylinder. It only works if the hue is an angle. And the way that it works is it's just like Zoolander. Like literally, sRGB has been like Zoolander this whole time, where it can, like Zoolander could only turn right. He'd get to the end of the stage and be like, oh wait, I can only turn right.
Not an ambi turner.
Not an ambi turner. That's awesome, dude. Now you can tell it to turn the other way. So basically it would always take the short path, right? It would always take the short straight shot, or it would always rotate around the clock the fastest way to get to its destination. And now you can say, hey, go the long way. And you can, there's been people on Twitter making fun demos of this where you can say, hey, I want a gradient from red to red, and I want you to go the long way. And it literally makes a rainbow because it took the long way around. It collected every hue all the way around 360 degrees. If you open up my color picker and you see that little hue strip that shows the rainbow, where you're choosing the hue, that's literally a color gradient that I've drawn from red to red, telling it to do the longest hue or the longer hue interpolation, and it'll take the long way. It's so cool. You used to have to make a gradient with like 12 stops in it to represent all the main hue points or whatever. And even then it might be a little wrong. Now it's right. It's really cool. Yeah, hue interpolation. That's a new one too. That's getting deep into the weeds of color as well. Because that's the color space offering a feature of an angle rotation. Yeah, it's cool stuff.
Blowing my mind. This is super cool.
Yeah.
And it's all typed, Nick. It's typed from top to the bottom, dude. Typed. You can't break it. It'll only work if you pass in proper, length percentages or lengths and stuff like that. It's good stuff. Or angles, which means you can pass rads to it. You'll be like, that's one of my favorite colors to do is too rad. Oh yeah, this color is too rad. Dad color joke.
This tool is really cool. And I'm looking at the CSS that is like, you have the modern gradient and then a classic gradient for each afterwards. And like, I was just curious because I was looking at some other example too. And this like English just in the middle of the gradients is blowing my mind. I don't even know how to search for it, but it's like from 0 degrees at center in OKLCH decreasing. Like I don't even know. I don't know. My brain is shut off.
No, that's really good. So, and if you look at the classic one, it has a lot of the same English in it. One of the differences is the in keyword, which is new with color spaces. So you have these like definitions about the prelude, or like the first part of your gradient there is about size and position. And now we have the addition of which color space do you want it in. And that's where those things are coming from. And that's sort of what I wanted my tool to also do, is because if you go to like, I don't know, some other gradient generator online, they don't tell you that there's these keywords, and some of the keywords are rad. Like to top right is responsive out of the box. Like if you said 45 degrees, it's not responsive. It'll stay straight. And you can see that in the tool. As you resize the box, you'll see that the degrees stay still. But if you do top right, it literally takes the first color and makes sure that it ends perfectly at the bottom left corner, and that the last color ends perfectly at the top right. That's why as you resize the box, the gradient line changes to make sure that in the top right is the last color perfectly ending at the corner's edge. And then if you go to the radial tool and you look at things like farthest side or nearest corner, my tool now visualizes that for you so you can see what it's doing. And it's really rad stuff. So some of these keywords, some of these features that are inside of gradients, they've been hidden for years. And I'm hoping this tool unlocks them for people and they realize that I can put a gradient in the center with just a keyword. Like that's awesome. And all this stuff. So I'm hoping it's like multi-prong here. It's giving you access to wide gamut colors, spec compliant color picker, spec compliant wide gamut gradients, and then just spec compliance in general, that the tool is facilitating these things for you. in terms of the linear, conic, or radial's powers. What are its superpowers? Including double positions. Did you pull the second percentage on one of those color stops? Such a hidden feature of gradients that people don't know exists is double stop. You can have a double position gradient, and you'll see my tool will split the circle in half, and then you'll have two crescents.
Yes.
I was wondering what was going on there.
And Nick's nodding his head. He's like, I see the two crescents.
Yes.
Okay, so you got like a color stop. You got a color stop that says, all right, just start the color here. And then you add another color stop and it says, all right, and move it from this color to that one to the other stop. But if you split it, you say, I want this color stop to span a range and then transition to the other stop. And it also has superpowers, like you can set the second one to 0 and it creates a hard stop. So your gradient, your color goes, up to 10%, and then your second position said 0, and it will end there. And you can make hard stop gradients really easy by using the double position syntax. I also, in my tool, have transition hints. And those are the sliders in between color stops, which allow you to tell it how to transition between the two, which of the two colors is more dominant in the interpolation from one to the other. And then I visualize that on the gradient too. You can see the little arrow thing and you can drag it and see how it changes the gradient. So it's like, there's been hidden superpowers in here that's like specialists have only known. And I'm like, no, people need this. They need this in their hand. And so I started building a tool to like put all this into one and help folks out.
This is awesome. It's like those videos of people doing like elaborate tie-dye patterns where they're folding things in very specific ways and then, putting the dye on in very specific ways. And then they get this amazing pattern at the end when they hang it up. I was watching one of those on Reddit recently. And so.
Sounds mesmerizing.
Yeah.
It does.
That's kind of everything. I mean, yeah, I mentioned Open Props has some stuff in there too. So if you want to start in this like next gen color stuff, there's some good starter packs for you there. They're in beta right now. Right, there's no Firefox support, so I'm just playing with this idea, but I really like the way that it's headed right now, where that you just import this one set of 15 custom properties, and then you can just change them however you want, and then you get any color palette of any hue perfectly from light to dark at any amount of vibrance that you want. So no longer will you visit a website and be like, I've got 12 colors to choose from. I can choose jungle or grape or, lemon. That's gone. You're just going to pull in 15 props and be like, no, hue 210. That's our brand hue. And now I got an entire palette that's perfectly, perceptually linear lightness. And you go nuts. That's really cool.
This is such a cool tool.
It's just moving the sliders back and forth.
Yeah. I also love that it's like it's encoding it into the URL too, so you can share what you create as well.
You can definitely, paste it into the chat. Let's see what you made, yo.
Yeah, I was going to say,
monstrosity.
Challenge gradient.style and share with us on the socials what you come up with.
Totally. I'm excited to see them. And I had fun naming all of them. I got like Soundwave, Solid, yo. Oh, here, there's one in the HD example. It's called Solid. Click that one. Did you know a gradient can take just one stop and still be valid? You have to use the double position syntax because you can say, hey, I want this color to span from 0 to 100%. And now it's a single color stop gradient that goes all the way across the canvas. And a lot of people would reach for a background color to do this, and you don't have to. So if you do a multi-layered gradient, you can put solid colors in there that way. And this tool visualizes it for you, which I think is really unique.
Mm-hmm.
Yeah, this is the best kind of learning environment.
Yes.
Right, you're just kind of figuring things out as you go.
Yeah, here, I'll share that one in the chat there. I tried some compression algorithms on the URL too, so I could fit more color stops in there. I was using a base 64 and some other things, but I liked the readability that you have right now. You can kind of parse the URL and it doesn't look tricky. You're not going to get sent a URL. It's like, if I click this, what's going to happen? I see some obfuscated data. That makes me feel uneasy. And so now it's not obfuscated, but anyway.
It might as well be straight CSS for me at this point.
Yeah, SvelteKit has been awesome on this tool. I already liked Svelte, but man, it's been phenomenal. And then it is TypeScript, but I use a very light amount of TypeScript. I'm like, I just kind of understand my code. I don't want to go nuts with types because it just is a slippery slope for me. I'm like, I'll just type this parameter. I'll just type its return type. And then it's all of a sudden I'm like, oh, what did I do? My function was already working. There was no bugs. What am I doing? You're like, I'm hardening it. You're like, yeah, I guess. I need tests though. I do need to write unit tests and stuff. I don't have those yet.
Oh, you have types. That's a good start.
That's all you need.
Light types. I'm a light typer these days. I've been to the dark side of heavy typing, and I'm like, no, I'm a light type.
Yeah, there's a balance for sure. It's like that. Not now. Someone's wrong on the internet. Not now. There's a type that's slightly incorrect.
Somebody put any in my code base.
Well, you understand SDR versus HDR now, and you're like, I got some new functions to go try. Yeah, what's remaining in your mind other than like it's just a very changeable thing. Your eyes need to see it. Your fingers are going to change numbers in these color functions, and you're going to see the results. That's definitely the next step is to go play. So yeah, hopefully this playground is good for that.
Yeah, definitely it is. It gives you good ideas on how to do these things. My mind is empty at this point trying to make sense of any of this, but I definitely see the value of these new color values. It's just when to or how to practically apply them is still like the difficult part for me. And it mostly comes down to like if I receive a hex color from my UX team, I'm probably going to use that still. So the tooling needs to come around. But yeah, totally. It's really cool.
Yeah, that's why I'll share my site in the chat there just because, you'll open it up and you'll be like, nothing here really looks HD, but it's me being the designer that in like a subtle way. Like the background color is not black; it is very dark, rich, cool gray. It's like, and if you open up the color picker, Chrome DevTools has cool features for this too. So does Safari, by the way. Like if you're debugging this in the browser, the Chrome DevTools color picker is updated now. You'll see a cutoff where display P3 is, kind of like you saw on the oklch.com. You can convert in that tool between color spaces. But it's really nice to visualize when you're like, this color doesn't feel that bright. And then when you go see and you drag the thing down into the sRGB color and you're like, oh, okay. Like when I see it downgraded, I definitely feel that, but you might not get that sense immediately that it's somehow special. But I don't know. This is one of those things. That's why Apple has had it for so long before everyone else. They knew that subtlety couldn't be articulated by many, but that they would feel it and see its excellence. And hopefully that's what you see on my site too. Like if you look at my code snippets on any of my blog posts, you'll be like, wow, those colors are really neon. That's because I'm definitely pushing those to display P3 maximum. That's fun stuff.
I did notice that, and I want a Vim color scheme based on that now.
So yeah, how long until VS Code has HD color support, and all of our color themes now have better dark colors, richer dark colors, whiter whites, and more vibrant neons for all of our highlighting. I'm serious. We're all going to switch to color themes that are HDR.
That's going to be amazing. Well, cool. Yeah, we will have all of these links in the show notes, including gradient.style, which you heard about here first. Go share your amazing gradients on the socials and with Adam, and join the Discord. Adam, anything else you want to add?
No, y'all's show is so good. I really appreciate you having me on, and continue the amazing content. Don't stop this. It's just, y'all rock. Really appreciate it.
It's just because of amazing guests like you. So thank you for coming on. And Amelia, you want to add anything else?
No, I'm stoked to try this stuff out.
Same. Yes. I can't wait. I'm going to share a couple of gradients and see how they compare. Cool. Well, thank you so much for coming on, and we will catch you next time.
See you around.
One cool thing about our new changelog newsletter is that we don't proxy links like almost everyone else does. That's awesome because A, there's no tracking, and B, you can hover on a link to see where you're headed before clicking. I do that all the time. If you appreciate direct links as much as I do, pop in your email address at changelog.com/news because the software world moves fast and we'll help you keep up the easy way. Special thanks once again to our partners Fastly and Fly for helping us bring you awesome pods each and every week. And of course, thank you Breakmaster Cylinder. These beats are banging. Next up on the pod, Dax Rad from SST joins Nick and K-Ball to talk about Open Next, an open source Next.js serverless adapter. Stay tuned right here. We'll have that episode ready for your ear holes next week.